What's up, everybody? Today we are going to be continue looking at polar coordinates, and we're going to start off by looking at a quick little investigation with the same Geogebra Applet that I had pulled up yesterday. If you want to follow along within your notes, this is linked in. Should just be on this screen. Click right here, open the link up. Now again, this is the same applet from yesterday. There's just some questions below the applet that I just didn't get to yesterday, okay? So first question says to plot the points 3 pi over 2 and then -3, 3 pi over 2, and see what we notice, okay? So we already have r to be 3, so we'll do the pi over 2 first. You can just type the word pi and then divided by 2, hit return. Use your slider now. So we're going to rotate our pi over 2 or 90 degrees, and then we learned yesterday off the terminal side of that angle, we'll just move 3 units upward, right? So there's our point. Okay, now let's rewind here. Let's change this to 3 pi over 2. And let's make r -3. Slide. So we're going to sweep out the 3 pi over 2. Now the terminal side of that angle would coincide with the negative y-axis, right? But we learned yesterday that when the r value of your point is described negatively, that means you actually have to extend that terminal ray in the opposite direction, right? So we're actually going to move 3 units up again, and we are going to wind up at the exact same point as 3 pi over 2. Okay? All right, so what we should be taking away from this is that any point, when it's listed with polar coordinates, it can be expressed in an infinite number of ways, right? Because of this use of positive and negative r values. Notice that the two angles here for these points, they're just pi units apart from each other, okay, or 180 degrees apart from each other. So if you want to take a point and express it with the r value being the opposite of what it originally was, all you have to do is add or subtract a multiple of pi or 180 degrees to the original angle, and that'll give you the same location, okay? Now understand, you could also just do this in terms of coterminal angles. So let's go back to r being, let's rewind here. Let's make r 3 again. And then let's make this back to pi over 2. Okay, so we sweep that out. There's that initial point, right? So what we could do is we could add a multiple of 2 pi to this angle, and we'll still wind up in the same location. So if I took pi over 2 and I added 2 pi, that would take me to 5 pi over 2, give me a coterminal angle, right? Okay, so rotate your 5 pi over 2, coterminal angle, 3 units up, we're in the same spot. All right, and that's what the second question really wanted us to get to. Can you come up with a different set of polar coordinates for the location given in the first question? Absolutely. We just came up with a third possibility of 3, 5 pi over 2. Now this is expressed in your notes here. So on example 3, we can see from the investigation that a point with polar coordinates of r theta can also be represented by the following. If you want to keep r positive, all you need to do is take your angle theta and add a multiple of 2 pi to it. Remember this notation, I'm expressing this as theta plus 2 pi k, where k is an integer. Again, don't overcomplicate this. This just means you're adding or subtracting a multiple of 2 pi from a theta. Okay? Now, if you want to make the r value negative, yet express the same location, then that means you need to add pi to theta or subtract it, and then from there you could add any multiple of 2 pi to get a coterminal angle as well. All right, so we have an example to kind of drive this home here. Plot the point of 5 pi over 3. That would place us right here is 5 pi over 3, so 1, 2, 3, 4, 5 units off of it would put that point right there. So let's find two other pairs of coordinates that represent the exact same location. I'm going to do the first one by keeping my r value positive. Okay, so I'm going to keep r 5, and then I'm going to take the original angle of 5 pi over 3, and all I need to do is add 2 pi to it. Okay, so think from where that point's located right now, if I add 2 pi, it's just going to rotate me back to the same terminal side, right? And I'd end up in the same location. So that would now just be expressed as 5 pi over 3 plus 2 pi over 3 would be 11 pi over 3. Okay. All right, now let's say I wanted to express the same point but with a negative r value. So now r is negative 5. I'm just going to take the original angle of 5 pi over 3 and I'm just going to add pi to it. Okay. If I add pi, we know that that's going to take us right to here. This would be the terminal side of that angle. But since r is now negative, we know we'd have to extend back in this direction 5 units, and it would put us in the exact same spot, right? So that's going to lead me to negative 5, let's see, 8 pi over 3 as a second option. Okay. All right, now I actually have a second Geogebra Applet that we can use to practice this concept, and I want you to spend a few minutes doing this yourself, okay? There, unfortunately, none of our other resources, Delta Math, iExcel, WebAssign, they don't really have practice problems related to this concept. So this applet is going to be our way of assessing in real time whether or not we understand this, okay? So we have, right now we have the point of 3 pi, and I want to be able to express this point with a new set of coordinates, just changing the sign on r or leaving it the same and then adjusting theta accordingly. So we could just, we could keep r as positive 3. And then maybe we want to add 2 pi to this. That'll put us at a coterminal angle. So pi plus 2 pi would be 3 pi. Type the word pi. Okay, now don't hit return here. Just get out of your keyboard and notice it tells me that I'm correct. Okay, now let's say we wanted to express the same point but with a negative r value, negative 3. That means pi, the original angle, you'd have to either add or subtract a multiple of pi to it. Okay, so let's do pi plus pi, which would be 2 pi. And notice I'm correct again. Okay, now we can generate a new problem. I actually want to get one where their denominators, that'll work, 4, 3 pi over 2. So let's keep r positive 4. If I keep it a positive, then I'm going to need to add or subtract a multiple of 2 pi. So 3 pi over 2, let's do plus 2 pi. That should be 7 pi over 2. Okay. Or how about, let's make this negative 4. Then that means I could add or subtract just pi to the original angle of 3 pi over 2. So how about I add pi to 3 pi over 2? That would give me 5 pi over 2. Okay. Oop, I hit enter. Shouldn't have hit enter. 5 pi over 2. Don't hit return, just tap out and it'll tell you that you're correct. All right, so spend a few minutes practicing this yourself, generate a few new problems for you, make sure you got the concept down. That's it for today.